Hello students, this is Smita Patnaik from Electronics and Telecommunication Department. So today we are going to discuss about one more new topic, that is your optical fiber communication. So let's start our class. So optical fiber communication, okay, this is the term or a technique in which the signal is transmitted over a long distance, and first the signal is transmitted which is converted into light signal, okay, that is a medium for moving those light signals from one location to another location. Okay, so here what happens, the optical fibers are generally used as waveguides that carry these optical radiations. Okay, they are very thin, long and flexible fibers which is made up of your silica or glass material. Here, a signal transmitted through an optical fiber is transferred from an electrical signal into light signal, okay, which is then converted back into an electrical signal at the receiving end. Okay, so here optical fibers are used in modern optical communication and also in telecommunication systems, because here the data can be transmitted over a long distances without much attenuation and distortion. Okay, so this one is the total optical fiber communication. With this when the data is transmitted from one end to other end, this fiber have very little loss even if the fiber is bent or coiled. Okay, so that's why these optical fiber communications are used. Next, this diagram indicates the structure of optical fiber. Okay, here so some components are there. First is your core component, which is the inner part. Next, cladding, and yellow part is your strength member, and last one is your outer jacket. Okay, so the optical fibers are made up of glass or silica material, and the diameter of the core is in the range of some few micrometers. Okay, the diameter of the outer cladding is somewhat 100 to 120 micrometer. Okay, which will protect the core. And last one is your what, the protective outer covering, which is used on the top for the mechanical protection. Okay, the last outer jacket is used for your mechanical protection. So these are the some basic components of your optical fiber. So this diagram here represents the structure of optical fiber. Next, some basic components of optical fiber. So here first component is your core. Okay, the central part is called the core, where it is made up of a higher refractive index glass, and surrounding region is called your cladding. Okay students, so here core is used for carries the signal. So that is its diameter is somewhat 8 micrometer. Okay, then the outer part is called your cladding, which has lower refractive index as compared to your core. Okay, so next it has the diameter of somewhat 125 micrometer. Okay, so next your yellow color part is your buffer, which is clearly visible in case of this diagram. Okay, so buffer is mainly protects the fiber from the damage or any moistures. Next here last one is your jacket. Okay, it is used to protect the optical fiber, okay, which holds one or more fibers in a cable. Okay, when the signal travels from your what, lower refractive index to a higher refractive index, okay, the cladding is used to reduce your scattering. It adds mechanical strength to the fiber and also protect the core. Okay, when the signal is internally transmitted, the signal is totally internally reflected, okay, from incident angles greater than a certain critical angle. The light rays which enters the fiber at an oblique angle gets totally internally reflected at the core and cladding interface. These rays undergo multiple reflections and arrive at the other end and without much attenuation. Okay students, so this is the total components of your what optical fiber communication. Next let's start about the types of optical fiber communication. So depending upon refractive index, it is classified into two types, that is your step index fiber and gradient index fiber. And second one is your depending upon material used, it is again classified into two types, that is glass fiber and plastic fiber. And last one, depending upon mode of light propagation, it is again classified into two types, that is your single mode fiber and multi-mode fiber. Okay, so let's discuss here single mode and multi-mode optical fiber. Okay, so there is a difference table here between single mode and multi-mode. In case of single mode, what happens? Here only one mode of propagation is possible, but in case of multi means what? Many. So here many mode of propagation is possible. Okay, the diameter of your single mode is somewhat 9 to 10 micrometer, and but in case of multi-mode, the diameter is 50 to 62.2 micrometer. Okay. Next, the difference between refractive index of the core is very small in case of a single mode, but in case of multi-mode, the difference between the refractive indexes of core is very larger. Okay. Next, here what happens? The fabrication process is very difficult in case of single mode, but the fabrication process is very easier. Okay, here the process of launching of light is very difficult, but in case of launching of light is easier. Next, fiber is very costly one, and these are also used in what telecommunications and TV networks. But in case of multi-mode, the fiber is very cheaper. These are used in local area networks and security systems. So these are the some basic differences between your single mode and multi-mode step in optical fibers. Okay, so let's discuss about your characteristics. Okay, here so many characteristics are there, but we will discuss some characteristics. Okay, so here first one is your wide bandwidth. Okay, here what happens, the signal will which is transmitted over a long distance, over a long distance, it will having a larger bandwidth. Here the fiber systems have more capacity, so that much signal we can be transmitted. Okay, so next come to your low attenuation. Low attenuation means when the signals transmitted from one end to other end over a long distance, okay, it there is a signal loss will be there, but in case of optical fiber communications, there is a no signal loss each occurs. That's why it is low attenuated. Okay, next, enhanced security. The data is transmitted that is more secure than other communication systems. So these are the some basic characteristics of your optical fiber communications. I hope you understand. Next come to your some advantages of optical fiber communication. Here first advantages is your greater bandwidth and faster in speed. Okay, because here the signal is converted into light signal. As we know, the speed of the light is very fast, so this one is extremely high bandwidth and speed also higher. And last second one is your it is very cheap. Okay, here long continuous and miles of optical fiber cable can be made cheaper than equivalent length of copper wire. Okay, as compared to other systems, it is cheaper, and low attenuations are there. Next, high speed of transmission over a long distances, and these optical fibers are small in size and low in weight also. Okay, so less signal degradation. Okay, the loss of signal in optical fiber is less than in copper wires. So these are the some basic advantages of optical fiber communication. Next, some disadvantages. First one is your low power. Light emitting sources are limited to low power. These high power emitters are available to improve power supplies. Okay, by using some power supplies, we can improve our low power what consumptions. Okay, it would add extra cost. If we add some amplifiers, in case of optical fibers, it will take some extra cost. Okay, next fragility means flexibility. Okay, here the optical fibers are very smooth in characteristics, so that the signal is transmitted from one end to other end very fastly, and we cannot twist or bend this fiber so that it can what damaged. Next, distance. The distance between the transmitter and the receiver should keep a short or repeaters. Okay, if we use for long distances, then we will use some amount of repeaters to avoid attenuation. Okay, so these are the some basic disadvantages of your optical fiber communication. And last one is your applications. So these are used in a defense purpose. Okay, in medical sectors. Okay, in medical means in case of laser surgeries, endoscopes, etc. These are used optical fibers. Next, industrial applications means in laser processing of materials like drilling, welding, and cutting of your steel materials for building cars. Okay, these are used. Next, these are used in military conditions. These are used as military as sensors. Okay, that fusion for weapon systems. Okay, or military aircrafts also these are used. And in case of telecommunications and optical fiber communications, the optical fibers are used. Next one is your in civil. Okay, these are used also sensors to measure strain and temperature and pressure. Okay, in case of civil. So these are the some basic applications of your optical fiber communication. I hope you understand. Thank you.